Okay, this problem is dealing more with the systems of equations stuff that we've been working at. So I'm going to put a couple different types of problems up here to show you how I would solve them differently. So this first system that I have up here, and again, a system is just more than one equation. I'm trying to solve for x and y at the same time. And if I graph these, I'm looking for where they intersect with each other, the points x and y that would work in both of them. And so this is the problem is asking me to solve these without graphing them. So first thing I would notice is that y is negative 2x plus 2. So I could say y, or I could say negative 2x plus 2, because they mean the same thing. So what I would do in this problem is I would replace this y up here with a 2x plus 2. So instead of being 4x minus 2y equals negative 4, I'm going to put in 4x minus 2 times negative 2x plus 2 equals negative 4. So all I did was I replaced the y with a negative 2x plus 2. And now I'm going to solve it just like I'd solve any other problem. So 4x, and then I see that I can use the distributive property to get rid of those parentheses. So plus 4x minus 4 equals negative 4. Now, when I add 4x and 4x together, I get 8x. And now if I add 4 to both sides, I get 8x equals 0. The only thing for x to be then is 0, because 8 times 0 is 0. Once I know what x is, I'm going to use that same method of substitution to plug 0 in for x. So you can do it to either equation. I think it's easier to do in this one. Y equals negative 2 times 0 plus 2. So again, I'm just using substitution because I know x is 0. So y equals 0 plus 2, or y equals 2. That means that at the point 0, 2, these two lines intersect. Or x equals 0, y equals 2 should work in both of them. So I might look up here and check that. 4 times 0 minus 2 times 2, that does equal negative 4, so I see that checks. Okay, the next problem I'm going to put up there is slightly different. This time I'm going to put a parabola, y equals x squared, and a simple line, x minus y equals negative 6. But I think I'm going to use substitution again because that's probably the easiest route for me to take here. I see here that y is x squared. So I could say x squared, or I could say y. They mean the same thing. So I'm going to take that y and I'm going to replace it with an x squared. And the advantage of that is that now I'll only have one variable to solve for. So instead of saying y, I'm going to say x squared, because y and x squared are the same thing. Now I see I have a quadratic, and the reason I know that is because I have one x squared term and an x term by itself. Whenever that happens, I have to set it equal to 0. I can't use the linear way of solving. So I think I'm going to subtract x and add x squared to both sides of the equal sign. So now I have 0 because x minus x is 0 and negative x squared plus x squared is 0. Equals, and I'm going to write this in order, x squared minus x minus 6. Now the only way I could, well, there's a few ways I could solve this, but I could use quadratic equation or the quadratic formula. I'm not going to do that. I am going to factor. Some of you use the Xbox to factor, which is fine by me. Some of you just do backwards FOIL to factor, but we're looking for the two factors. That'll give me x squared minus x minus 6 when I multiply them together. Okay. So they're going to have to multiply to be negative 6x squared. They're going to have to add up to be negative 1x. And when I find the area, this is going to be x squared, this is going to be negative 6. So I can start finding the factors just by using that box, which some of you just use that. But I see here if I use negative 3x and positive 2x, those add up to be negative 1x and they multiply out to be negative 6x. So I'm going to fill those in, negative 3x and positive 2x here. And if this side is x, then this side is going to have to be 2. If this side is x, then this side is going to have to be negative 3. And there's my factors, x minus 3 and x plus 2. So I found my factors. They're x minus 3 and x plus 2. But now I also have to solve. So I know that anytime I take something times something and it equals 0, that means that one of those things has to equal 0. So either x minus 3 is 0 or x plus 2 could be 0. So in this case, x is 3. In this case, x is negative 2. Unfortunately, I'm not done with the problem yet because I've only found the x value. But remember, this is a system of equations, so I'm looking for x and y. So now you can go back up to the original equations that you were given, which were x minus y equals negative 6 and y equals x squared. And you can use those to find your final answers. So if x is 3, 3 minus what equals negative 6? The answer is 9. So when x is 3, y is 9. And when x is negative 2, negative 2 minus what equals negative 6? And the answer there is 4 when you solve it. So my two answers are 3, 9 and negative 2, 4. There's two places where those graphs intersect. And remember, that makes sense because one is a parabola and the other one's a line. All right, so good luck with those problems, and hopefully this has helped you master that concept.